Okay, so imagine a photo eye here. So yeah, we're gonna start out basic. There's a photo eye, and you're gonna imagine a photo eye.
So that's blocked by that picture, right?
Yeah, it's blocked. It's blocked. Yeah. So you guys are all familiar with the photo eye, right?
Yes.
Okay. So a photo eye obviously is probably the simplest example here. It can either be blocked or unblocked. Okay. And that blocked or unblocked photo eye is going to be hardwired in through some way to a PLC, usually input card. And in that input card, the PLC is going to interpret it as a 1 or a 0, blocked or unblocked. Okay. Now, in that PLC, it's going to be mapped in a HMI status routine to a status array. And like I said, because reads are expensive, we're going to package everything together that ZOE needs into this status array. So that way all the information is organized, easy to reference, as well as we can do like 100 dint array reads at a time. Do you have a question?
Mm.
Okay.
No, that was somebody kept poking it. 4 times.
It's the other Tim. It's the other Tim.
The other Tim.
The other Tim.
All right. So, like I said, we don't want the all the HMIs to read this information because we could have 1 HMI, we could have 10 HMIs. If they're all reading the information at the same time, the information could be different, isn't ideal. Also, we're doing 10 reads, or we could just be doing 1. So all of this information is read by the PLC service. The PLC service is reading that information and then broadcasting it out, if you will. Shashen has worked to develop kind of a modified version of the subscribe method. So it kind of broadcasts this information out of what the current status is of all of the status bits. And if you subscribe to it, then you get that information. So the PLC service is going to read, it's going to be a block with numbers in it. Every dint is going to have the actual dint value. You guys are all familiar with dints?
Memory.
Yeah.
Yes.
Okay. So if you only have 1 bit in that dint array, and it is 1, then you'd have a 1 value. If you had multiple dints in there and they're 1, 0, whatever, it's going to be a different number that's going to come out. But all of that's going to be packaged into 1 number for that 1 dint. The status array is, it needs to be in a specific order. The first dint is going to be the revision number of the HMI code, or the HMI code. So in the database, there's also usually in the storage table, there's a HMI code version, and that number has to match that first status number. And the reason for that is so that way we can tell that from the database side to the PLC side matches, that information matches. And then you can have any number of dints, but then the second to last dint is going to be the total length that the service needs to read. So basically, it's the total length and number of dints plus one to account for it, itself. And then the last dint is also the version number. And the reason for that is so that way the PLC service can tell that it read the entire thing. Because if it lost communication halfway through, it knows that that part of the chunk isn't the whole thing. So we have a couple checks there to make sure we grab the whole data and that it's the current version of data. So, like I said, the PLC service interprets it as a block of numbers and then just sends it out. It doesn't care who's reading it, it just sends it out. So who grabs it is the alarm service. So the alarm service it pulls that information in because the alarm service needs to care about, what alarms are active. So it needs to know all the PLC tags that, and then the HMIs all grab it, obviously. And then at the end of that, you have to have some kind of cross-reference between what the actual PLC tag is and what the bit and dint in that status array are. So you end-to-end know that you're looking at the right photo eye, that you're looking at the right conveyor. So then you have an end-to-end cross-reference. And that's the database. And in the database, there's HMI underscore code table. So the this information, the status dint, the status routine, and the database HMI underscore code table is a majority of the time going to be generated by Adept. Are you guys familiar with Adept? Okay, so for Jack, Adept is another in-house product, if you will, that we kind of created that helps us get 80% of the way there. So the idea is that a majority of our projects, at least 75, 80% of the time, it's the same, right? The conveyor is going to divert the same way, every time. Exactly, it's basically a template. So Adept generates the LK5 files for the Rockwell software, so the PLC engineers can just import that, and they have a good starting point. But it also creates for us the status code and the HMI code, or for the HMI underscore code table information. Now, there are times, there are quite frequent times where Adept is broken. And there are manual ways of working around it. If you need to, so on the file server, just on the base file server, you don't have to dig any deeper, is ZOE training folder. And in that ZOE training folder, there are some helpful documents. Everything I passed out today is in there. This video that we're recording is going to be in there too. So you can rewatch if you want. But also in there, there's going to be a document that helps you, here is the HMI tag generation. So that document, I'm not going to go through it right now, but that document will help you generate the status array code and the HMI underscore code table. If there is any issues with the depth, there's a script that you can run that helps you generate it. There's a couple different.
Do you have this
methods.
PowerPoint for this in this folder?
If it's not in there, I will add it in there.
That would be great.
Yeah,
Just to do a quick review.
exactly.
Appreciate it.
So yeah, to go around one more time. So the photo eye gets blocked or unblocked, comes to the PLC, is 1 or 0, moved to a status array, read by the PLC service, and then translated into a block of numbers for every DINT. Then broadcast up to the alarm service and the HMIs. The HMIs then can cross-reference that information to see, to make sure what number relates to what bit. And then on the HMI, we can have a green or gray display for that photo eye.